Thank you so much. Thank you. So I want to discuss about models, AI, nothing new. But right now we have a lot of models like LLMs, classic models, and we need to define what we should use for our, what is the best approach for us. But before I start, let me introduce myself. I'm Tomasz Jażdżewski. Normally I'm a MLOps engineer, but besides that, I'm also an academic teacher. And from the beginning of my career, I'm trying to combine science with business and make sure that I teach those skills that are needed for my students after the graduation of the university. So the question is, classic machine learning dead? What does it mean? We have large language models and they outperform. And before that, we have some classic models like decision trees, neural networks, some basic neural networks that has been used by a lot of people, but not so popular. I would try to define what is the difference between classic machine learning model and large language model with 4 steps. So first of all, I would try to introduce you some history of AI to show you where we are right now. Then we need to define what is the large language model in our cases to make sure that we are on the same page. After that, let's define some approaches, which is what approaches suits me better. And on the end, I will give you the brief summary of those 2 models to make sure that when you think about the problem, you probably think also about the proper solution. So, how it started? So, we're trying to implement human knowledge from more than 100 years. So as you can see, in previous century, already started implementing something called fuzzy logic. After that, we started implementing the math models that are used to implement neural networks. Right now, we are in an interesting time because we can consume the ears of the researchers. So right now, we're just consuming something that has been created, let's say, even 100 years before. And right now, let's think about the classic machine learning. What is that? So for me, and probably for a lot of use cases, classic machine learning are the sets of algorithms that can solve on a unique problem. What that means? We have some anomalies that we need to detect. Our model needs to find those anomalies, and we probably have some data that describe those anomalies. And the problem is that when I have that model, and that model knows what is the anomaly, probably it only knows that anomaly. What does that mean? When I have something called image detection, image segmentation, I need to create a new model because the previous one doesn't know what is an image. So I need to create one model per one problem. On the other hand, we have these large language models. And the thing that makes them so much attractive is that they can consume a lot of unstructured data because they can tokenize the input. So they can consume images, time series data, text, music. And what is the most important thing? When we use LLMs, the model already knows what is the image, what is the music, and we can just give the piece of information and get the result without training and building the model itself. So it's like the ready tool out of the box. And the question is, what suits me better? Let's define it in some different aspects. The question is, do I need to build a car to have a car? What does it mean? Let's imagine that our business problems, our business daily routine is like a road. Some parts are common like highway, and most of the cars probably can pass that highway. But some parts are like racetracks, so we need F1 car. Some of those parts are like off-road parts, so we need off-road car. And of course, life is much complicated that we can define it with those two examples. So our car looks like on this third page, third image. And let's think about classic machine learning models like parts of a car that we can use to build our unique car for our unique problems, to solve our unique problems. And LLMs we can use like a ready car, but we need to adapt it to our problem. So right now we can ask, is it easier to build your car from scratch or adapt the current one you have? How I'm going to do that? So let's start with defining AI problem. We need some problem and we need to define how to solve it with AI. When we have defined a definition of a problem and how we want to solve it, we need to build it. After that, deployment, and on the end, we need to be sure that our solution can be updated, because everything is changing and every solution needs some updates to make sure that it will perform on a high level. So, what we have? Imagine that you have some unique problem. That problem describes your business problem. So if that is your core business problem, probably you have the best data that describe that problem. And what is the most important thing? That the inputs, so those data, are unique. I probably wouldn't understand it if you will not explain it to me. You need some special guys that have some domain expertise, and thanks to that, they can understand those data. The same with the output. When we have some unique output, then I would say with some classic machine learning models, sales prediction, I wouldn't even understand what that model trying to talk to me. But the other guy that knows that the problem will understand it with no problems. And on the other hand, we have some daily routines like recruiting, and we need to analyze a lot of CV files, and it's not our core business. And this is something that can be done by a lot of people. When I need to find the best CVs files, I just need the input, which is, I need this tech skills. So thanks to that, I can match the best CVs to such an input. And the problem is that input in this case is unstructured. Probably some CV files have more images or more text, and we cannot control the input. And this is the case where LLMs probably should be used. But when we have the unique data, unique problem, and unique knowledge about the problem itself, probably we should use the machine learning models, classic machine learning models. And then, when you talk about building a model, we need to answer for those three questions. Do we have a time to validate our model? What does that mean? We've built a solution, but we need to test it. Probably in some classic machine learning model, it takes some time because we need to make the EDA, then we need to train the model, validate it, and then fix the model. Okay, so but when we have the time, okay, let's wait. Then we need to find out if we have proper expertise in our company. Those guys should understand the business problem, should know how to build a model, how to prepare the model, how to deploy a model. And if we have such a guys, good for you. And on the end, we should know if we have the proper data that describe the model itself, or at least allows us to validate the output from such a model. If yes, that's good for you. But if not, I would think about the problem one more time. Maybe the problem is too complicated, or maybe it's too big, or maybe we are not ready to create AI solutions. And what is the most important thing in terms of comparison of classic machine learning models and large language models? When we have large language models, I would say we have something like which is called sales approach. What does that mean? We have a problem, we provide some questions, and we have the results. And sometimes those results are good enough for us. But in most cases, probably we need to build something called RAGs, some prompt engineering, some data preparation, and also take time. So to sum up, ML approach is always take time, but with the LLM approach, sometimes there are some quick wins, but not always. Okay, we have our solution, we build it, and we need to deploy it. What that means? When we need to deploy model, we need to put it in our production and test it. So we need to think about the input data, the data from the production. When we use the LLMs, as I mentioned before, we use tokens. And the problem with those tokens is that when I have one word, it built from, let's say, 3-4 tokens, and I can mix them, and every single mix may create a different prediction. So if our solution is very sensitive for the input data, it's really hard to control the input data in LLMs. In classic machine learning model, it's much easier because we know the data, we know the edge cases, we know how to limit those edge cases. So yes, that's the difference. Then we have user interface. Probably most of you use LLMs. It's really easy to use them. And on the other hand, when we have this machine learning model, sometimes may be complicated. Sometimes you need to check the documentation. Sometimes you need to check data that has been used to train such a model, and also take time. And that's why user interface in classic machine learning model may be complicated. And optimization, what that means. So when we have a model, we can optimize it. So when we have this large language model, probably we have something from the ready model. And the problem is that it's optimized, it's already optimized. So because of the fact that it's already optimized and it's quite big, we need really good expertise. We need specialized tools to make sure that we can optimize the model harder. And on the other hand, when we have the classic machine learning models, the optimization can be also tricky. But it's less harder done with LLMs. And scaling. LLMs probably have more inertia rather than classic machine learning models. So that's why that make them harder to scale. And machine learning models, those classic, like decision trees, we can deploy as a microservice. We know how to deploy microservices on Kubernetes, something else, and we know the framework. But there is one thing. I've mentioned before that classic machine learning model can solve only one unique problem. Think about forecasting sales for whole year in monthly granularity. What that means? I have one product. I need the prediction of sales for January, one model. For February, second model. March, third model. And this is still one product. So we have 12 models for one product. But in pharmacy, probably you have more than one product, which is, let's say, 100 products. And now you need to manage with more than 1,000 models rather than the one. And sometimes can be tricky. Okay, but the thing about improving a model, so let's call it retraining. We need to make our model perform in the future, and we need to monitor it. And retraining classic machine learning model, probably in a lot of cases, it's automated. We just monitor the performance of the model, and then we trigger an automated pipeline, and that's good. And that's a really easy thing. But when we need to make our large language model better, then we need to think, what's the problem? Maybe we should improve our RAG, or the input data, or the prompt engineering. It takes time, and it's costly, and you need some special tools and people for that. So when we have some areas like this selling predictions, and the environment is changing quite frequently because the geopolitical things, marketing, etc., probably you need to update your model quite frequently. So machine learning models would be the best solution for you. But when we have some problems like word suggesting, or let's say this copilot things, there are some changes, but probably you need to update the model once a year, once and a half year, and that's not the problem. That will not block you to use the best model. And the final thing, do you need to understand a model? What does that mean? We have some example. We need to find out what is the difference between wolves and dogs. We have pretty good accuracy. And we want to deploy that model. But one guy asked, what is the difference between wolves and dogs? Let's check it. Let's see how model see the difference, because sometimes I don't know. And they tested, and the problem was with the data set, because all wolves has a snow in the background. So the model was focusing on such a snow, not on the face itself. So this is really important to understand what our model do and how it predict, because thanks to that, we build trust and transparency. And I would say what is the most important thing, we know what we can do better. Thanks to that, we can see what are the strong and weak points of our model. And how we can understand how our model predict. Let's make it easy, because it's quite complicated. In easy way, we just need to analyze parameters. Classic machine learning models can have from 1 to 10 million parameters. Probably it's YOLO 4, as I remember. And imagine that we can analyze every one parameter per second. So for classic machine learning model, it takes something like 100 days. Not so bad. Of course, LLMs has much more parameters, 2 zeros. Okay, 2 zeros, not such a difference. But it makes the difference. 32 years, not the days. So the problem with explaining LLMs is the problem with the numbers of parameters that are there. Of course, there are some tools, and we can do it even good, but still, when we want to go and make some deep dive to understand a model, and it's crucial for us, probably machine learning models, so those classic machine learning models, will be better for you. And when we talk about understanding a model, we need to also understand data. Because, as I mentioned from the beginning, building machine learning model, the classic machine learning model, it's connected with understanding the data itself. So when you have some experiments like this classic machine learning experiment, we have data scientists, data analytics, business analytics, domain experts, and they concentrated on data, so we can find out if the problem is in data, how we can find how we can challenge our process. Is our process collect all the data that we need? Maybe we collect too many data, or maybe we forget about something. On the other hand, we have this approach. I would say we mostly focus on the solution, not the data. So sometimes we can forget about the data, and we just miss the key points when we trying to build those unique business solving solutions. And let me just summarize this speech with some limitations of LLMs and classic machine learning models. So when you have a lot of unstructured data, probably you should use LLMs, because you don't want to proceed every single file in your database, maybe SharePoint, etc. But when you have some structured data, try to use machine learning models. Maybe machine learning models suits you better, and it's more optimized. So thanks to that, when you have some problems on edge devices like phones, whatever, machine learning models also suits you better, because of that you can optimize them much easier. And the same with the scalability. And when we talk about the human interface, I know, as I mentioned, probably most of you already use such a models, and I'm sure that no one of you use the model that I produce in this classic approach. because it's too complicated. And when I talk about this fast validation, yeah, classic machine learning takes time. So we need to prepare data, etc., etc. But large language models also take some time. It's not like always quick win, but sometimes it is. Maybe some chatbots. So yeah, sometimes we need to even try and test the result, but we shouldn't throw that LLM solve every single problem. And the final use cases, when we have something which is called prediction, segmentation, optimization, then you should start thinking about classic machine learning problem. And when we have something like document retrieval, user interfacing, chatbots, then maybe you should think about large language models. But what is the most important thing when we talk classic machine learning models? Data foundation. Without it, the risk that our experiment will fail, our deployment will fail, and our solution will fail, it's much higher. The problem with machine learning models is that we cannot make it enterprise without proper data foundation. In terms of LLMs, data foundation is not so, let's say, it's not such a blocker. Probably you can omit that problem, but when you want to scale it, make it more enterprise, you will find the barrier which you need to solve with those, break this barrier with this data foundation. So the final answer is classic machine learning dead. I would say it not. There is a lot of cases when we can use them. And what is the most important thing? I have a hypothesis that when we try to automate our daily routines with LLMs, then we can have more time to focus on building better classic machine learning models. So, yeah, I would say that's not the question that I just wake up and is classic machine learning already dead? But this is the brief summary of discussions in our company from a lot of domains, because I work with people from the front end, from back end, data, but also from a lot of business domains like logistic, insurance companies. And in a lot of discussion, there was the same problem. Why we are using LLMs? Sometimes the classic machine learning approach suits their better. So I would like to thank you for your time. And if you think in a different way, maybe I'm wrong, please convince me. I will be on the end on the conversation, on this event. Yeah, reach me out. Thank you so much.